So we're going to talk a little bit about even and odd functions. And suppose, for example, we start with the function f of x is equal to x cubed. Well, if we replace every value of x, let's say we replace x is equal to 2 with x is equal to negative 2, what happens to the output of our function? Well, f of 2, or 2 cubed, is equal to 8, whereas f of negative 2 is equal to negative 8. And so we can look at, well, what happens if we replace every value with its negative? We get a different looking function. On the other hand, if we graph negative f of negative x, we get the identical function. Another way to think about it is, while this function does not reflect onto itself across the y-axis, it does rotate onto itself if we rotate 180 degrees around the point 0, 0, or the origin. Every single function of this type where the exponent is odd is considered to be an odd function. Similarly, when the exponent is even, we have an even function. This is actually the origin of the name of even and odd functions. So now when we look at f of negative x, it looks exactly the same, because when we replaced 2 and f of 2 is equal to 4, when we replace 2 with negative 2, we get that f of negative 2 is also equal to 4. They have the same y values. And one of the ways this manifests is that this function rotates around the y-axis onto itself. On the other hand, it does not rotate around the point 0, 0 onto itself, unlike the odd function f of x is equal to x cubed. So we can see that as the exponent changes from an even to an odd, we can see that when we look at the reflection, when they're even, it reflects onto itself. When the exponent is odd, it does not reflect onto itself. However, when it's odd, it does rotate onto itself. And this is true even when the exponent is negative. So when we have x to the negative fourth, we can see that f of negative x is identical to f of x, but negative f of negative x gives us a different looking function. Again, that manifests as a function that reflects onto itself across the y-axis, but does not rotate onto itself. When it's odd, on the other hand, it rotates onto itself, but does not reflect onto itself. So if we look at some other functions here, we have f of x is equal to the absolute value of x, which again, when we look at f of negative x, it looks exactly the same as f of x. And it does reflect onto itself across the y-axis. If we look at the square root of x, now if we look at f of negative x, it's a different looking function. Negative f of negative x is also a different looking function. This function neither reflects onto itself across the y-axis, nor does it rotate onto itself 180 degrees around the point 0, 0. This is neither an even nor an odd function. F of x is equal to the natural log of x. Again, neither even nor odd, as we can see. F of x is equal to 2 to the x, not even or odd. F of negative x, in fact, is the same graph as 1 over 2 to the x. But this is not an even function, doesn't reflect across itself, across the y-axis onto itself, nor is it an odd function. If we look at the sine of x, we can see that if we graph f of negative x, we get a different looking function. And if we graph negative f of negative x, we get the same function. Again, the reason is it does rotate onto itself 180 degrees around the point 0, 0. It does not reflect onto itself across the y-axis. When we have a function like this, f of x is equal to x minus 2 squared, which is the same as x squared but just shifted 2 units to the right, now it's not going to be even or odd, because it's no longer, while it has an axis of symmetry, that axis of symmetry is no longer the y-axis. So it does not reflect onto itself across the y-axis. It would reflect onto itself across the axis of x is equal to 2, but does not reflect on itself to itself across the y-axis. Finally, we just take sort of an odd polynomial, doesn't go through the origin, it's not symmetrical around the y-axis, it's neither even nor odd. Does not rotate onto itself around the point 0, 0, nor does it reflect onto itself around the y-axis.